Hello and welcome to exercise 4, endocrine system physiology. And we stopped at activity 1's review sheet. So let's answer these very important questions. So we have already finished the experiment and we answered the questions for the pre and post lab. So now let's answer the activity 1, metabolism and thyroid hormones review sheet questions. So let's begin with part 1, labeled as determining the basal metabolic rate. So the first question is, which rat had the fastest basal metabolic rate? So we remember from our experiment that in our experiment we had that the normal rat had the fastest basal metabolic rate because it was not missing its pituitary gland or a thyroid gland. So we know that the other two rats, the thyroidectomized rat, had its thyroid gland surgically removed, and the hypophysectomized rat had its pituitary gland removed. So the entire hypothalamic pituitary thyroid axis is not complete. So it is only complete within my normal rat. That's why it will have the fastest. While the other two rats, because they are missing an entire component of their hypothalamic pituitary thyroid axis, then their basal metabolic rate will be lower. Why did the metabolic rates differ between the normal rat and the surgically altered rats? As we said, they are missing a whole component of their axes. So the normal rat had the highest basal metabolic rate because it had intact 3 glands: the hypothalamic gland, the pituitary gland, and the thyroid gland. And that is that system, that intact system, hypothalamic pituitary thyroid axis, is important for regulating the release of thyroid hormone. If you're missing a gland, then you're missing a hormone. Question number 3. If an animal has been thyroidectomized, the thyroid gland surgically removed, what hormones would be missing in its blood? Well, obviously the thyroid hormone would be missing, thyroxine would be missing, triiodothyronine would be missing, but thyroxine is tetraiodothyronine. For the thyroidectomized rat, the hormones missing will be triiodothyronine and thyroxine. Now let's move on to question number 4. If an animal has been hypophysectomized, meaning the pituitary gland was removed, the hypophysis was removed, what effect would you expect to see in the hormone levels? So if the hypophysis is removed, that means, as far as my thyroid hormone is concerned, then TSH will not be secreted. So for the hypophysectomized rat, the TSH will be missing due to the missing pituitary gland, and without TSH, the thyroid hormone levels will be lower than normal. That's why we will need exogenous thyroxine, known as levothyroxine. Let's look at levothyroxine. Levothyroxine is a medicine used to treat underactive thyroid or hypothyroidism. So a thyroid gland is unable to secrete thyroxine, so we would give it a, so that's the tetraiodothyronine T4 and T3 and thyroxine. They are my endogenous thyroid hormone. So now I'll be using levothyroxine, which is an exogenous thyroid hormone. Okay. Which rat had the fastest meta? We talked about that. Okay. If an animal has been hypophysectomized, we talked about this. So now moving on. Part 2 is the experiment. What was the effect of thyroxine injections on the normal rat? So when I injected thyroxine, well, the normal rat was hyperthyrotic because the thyroxine injections further increased the metabolic rate, but it did not develop goiter because there was no TSH involved. So when I inject a normal rat with thyroxine, then my cells are going to respond to that thyroxine. They will not say, well, this is not an endogenous thyroxine coming from my own thyroid gland, but it doesn't have to be endogenous. An exogenous thyroid hormone will do the effects. Okay. Question number 6. What was the effect of thyroxine injections on the thyroidectomized rats, basal metabolic rate? So now I want to know the effect of thyroxine on thyroidectomized rat. So I give thyroxine to a rat that has no thyroid gland, then the basal metabolic rate is going to go up. And how does the basal metabolic rate in this case compare with the normal rats BMR? Well, it's going to go up, but it's going to be a little bit below the normal rats basal metabolic rate. Was the dose of thyroxine in the syringe too large, too small, or just right? It is a little low. So because the basal metabolic rate did not go exactly to match my normal rats BMR, then that means the dose was too low. So the basal metabolic rate increased for the thyroidectomized rat with the thyroxine injection. Next question, number 7. What was the effect of thyroxine injections on the hypophysectomized rats BMR? So I have the pituitary removed. I add thyroxine. Obviously, the basal metabolic rate is going to go up. How does the basal metabolic rate in this case compare with the normal rat? Well, it's going to be less. It will increase, obviously, but it will not match the normal rat's basal metabolic rate. So that shows that the dosage, so they're asking, was the dosage of thyroxine in the syringe too large, too small, or just right? Then obviously it's too small because it did not bring up my basal metabolic rate to the normal level. Okay, part 3, determining the effect of TSH on the metabolic rate. So what was the effect of thyroid stimulating hormone injections on a normal rat? Well, the TSH is going to go right to my thyroid gland, causing a hypertrophy. So the effect of the TSH was to increase the normal rat's basal metabolic rate because it will stimulate the thyroid gland to secrete thyroxine, and it will also cause goiter development. Then, what was the effect of TSH injections on the thyroidectomized rats BMR? What was the effect of the TSH injections on the thyroidectomized rats BMR? Well, I injected thyroidectomized rat with TSH, then there is no thyroid gland to act on. So TSH comes from pituitary gland, and it binds like a lock and a key on my thyroid gland, and that is going to secrete a lot of thyroid hormone. But I have no thyroid in the thyroidectomized rat, so it will not affect the rat's basal metabolic rate. How does the basal metabolic rate in this case compare with the normal rat's basal metabolic rate? It's obviously going to be lower. Why was this effect observed? Because there is no thyroid gland to stimulate. So there was no effect on the thyroidectomized rat's basal metabolic rate with the injection of the TSH because there was no thyroid gland to stimulate. Question number 10. What was the effect of TSH injections on the hypophysectomized rat? So I have a rat that I removed the pituitary gland from, and I added TSH to it. Well, that doesn't matter because now that's an exogenous TSH. It will still go to my thyroid gland. My thyroid gland will not discriminate and say, hey, I only respond to endogenous TSH coming from my pituitary gland. No, it can also respond to exogenous TSH. So how does the BMR in this case compare with the normal rat's basal metabolic rate? Well, obviously it's going to increase, but in our results, it was not equal to the basal metabolic rate of the rat. So that shows the dosage was too small. So was the dose of the TSH in the syringe too large, too small, or just right? It was too small, and the syringe amount was too low. So that was question 10. Let's go to question 11. What was the effect of propylthiouracil injections on the normal rat's basal metabolic rate? And why did this rat develop a palpable goiter? Well, I know that my propylthiouracil will act on my thyroid gland and only my thyroid gland, not the pituitary gland, not the hypothalamus gland, not the hypothalamus gland. And it will inhibit the synthesis of thyroid hormone thyroxine, and that will that thyroxine is inhibited because propylthiouracil prevents the iodination of tyrosine residues, converting them into thyroxine, this thyroid hormone. So now the thyroid gland is not functioning properly, is not secreting the thyroid hormone. So the pituitary gland has no way of knowing that. So the pituitary gland will be secreting more and more TSH, and the TSH will end up overstimulating my thyroid gland to develop goiter and hypertrophy of my thyroid gland, and that will show a palpable goiter that I can palpate on a physical examination. So the effect of the propylthiouracil injections on the normal rat decreased the BMR, and the palpable goiter developed because of high levels of TSH in this rat. And without normal thyroid hormone secretion, the negative feedback on the pituitary is lost and TSH levels keep on rising. And that causes hypertrophy of the follicular cells within my thyroid gland. Let's move on to the question before the last, question number 12. And it says that, what was the effect of the propylthiouracil injections on the thyroidectomized rats BMR? Well, the thyroid gland was removed. So, and PTU only works on the thyroid gland, so it will have no effect because it only acts on the thyroid gland and it's not there. So how does the BMR in this case compare with the normal rat's BMR? And why was this effect observed? We said that the effect of the PTU injections on the thyroidectomized rat was not visible because there was no thyroid gland to be affected. So how does the BMR in this case compare with the normal rats BMR? It's really not going to the effect is just not going to be visible because it's going to stay. Obviously it's going to be hypothyroidic because the thyroid gland is not there, so we cannot be making the thyroid hormone, but PTU is not going to affect it. The last question is question number 13, and that would be, what was the effect of propylthiouracil injections on the hypophysectomized rats BMR? So now I want to see the effects of propylthiouracil injections on a rat on which I remove my pituitary gland. Well, who cares if the pituitary gland is removed? My thyroid gland is still there. That means PTU is going to overstimulate it. PTU is going to inhibit the synthesis of thyroxine. But since there is no pituitary gland and no TSH secreted, there will be there will no longer be any hypertrophy, and I will not see any palpable goiter. So how does the BMR in this case compare with the normal normal rat? So obviously it's going to bring it down because it's going to inhibit the synthesis of thyroxine. So the effect of PTU injections on the hypophysectomized rat was not visible because the rat is missing the pituitary gland. So the pituitary gland is no longer making for me my TSH, and there's no TSH. So you can have as much PTU inhibiting the synthesis of thyroxine, but in the end, there will be no thyroxine to inhibit to begin with. There's no synthesis altogether because there is no TSH coming from the pituitary gland. And that should be the end. Thank you very much, and see you on the next video.